Back, problem 5. Evaluate the following limits. Limit x approaching infinity, 3 over e power x minus 9, and limit x approaching negative infinity, 3 over e power x minus 9. Okay, so notice, as x approaches infinity, limit x approaching infinity of e power x is positive infinity. Okay, this we know. Now, limit x approaching infinity, e power x minus 9, well, that's just a constant. So this limit is still going to be infinity. So notice the denominator is getting large. So the quotient limit is 0. Okay, as x approaches infinity, this fraction goes to 0. What about negative infinity, right? As x approaches negative infinity, e power x is 0. So remember, this is an increasing function with horizontal asymptote as the x-axis. So on the left, you are approaching 0. So if I subtract 9, then limit x approaching infinity of the difference is negative 9. So of the fraction, that should be a negative infinity. Of the fraction, it is 3 over negative 9. That's negative 1/3. Negative 1/3. Good. Next, limit x approaching infinity, e power x plus e power negative x, e power x minus e power negative x. Okay. So e power x, e power negative x, e power x, e power negative x. On the top is plus, on the bottom is minus. Limit x approaching infinity. Well, this is a good one. So e power x has high growth, right? So I'm going to divide numerator by e power x, denominator by e power x. What happens? Division distributes. E power x gives me 1 plus e power negative x, e power x. So that bring that negative x to the bottom. I have 1 over e power 2x. Likewise for the denominator. E power x over e power x is 1 minus, get that down. So 1 over e power 2x. Well, now when I let x approaches infinity, this factor goes to infinity. So this fraction goes to 0. Likewise, this fraction goes to 0. So I have 1 plus 0, 1 minus 0. That's simply 1. Next. Find the derivative. E to the x plus x to the e. E to the x plus x to the e. Derivative of e to the x is e to the x plus derivative of x to the e. Remember, e is simply a number. So bring the e down, x to the power e minus 1. So what is the derivative? Derivative is, let's write it down. Derivative is e power x plus e x power e minus 1. That's it. Next. Find the equation of the tangent line at this point to this curve. So first, let me go through this carefully. So your curve is x to the power 4 plus 4 e to the power x. At the point 0, 4, always first check that the given point is on the curve. That is, substitute x equals 0. When x is 0, that goes away. E to the 0 is 1, y is 4. Alright, so 0, 4 is indeed on the curve. To find the slope, what do we need? We need to take derivative. Slope of the tangent line at the given point. Slope of the tangent at x equals 0 is derivative of y with respect to x evaluated at x equals 0. What's the derivative here? 4x cubed. What's the derivative here? 4e to the power x. Evaluate this derivative at x equals 0. That goes away. E to the power 0 is 1, so that's a 4. Slope is 4. Point is 0, 4. Equation of the tangent line. Once you have a point and slope, the point slope form is y minus y coordinate is slope times x minus x coordinate. You see, of the point AB. So y minus y coordinate is slope times x minus x coordinate. Y minus 4 is 4x. Y is 4x plus 4. That is the equation of your tangent line. So notice, once you write it in slope-intercept form, it is unique. So you have to write it y equals something. That's what they want. Next, find the integration of e power 3x times 3 dx. All right, so this calls for substitution. Substitute u equals 3x. Then du is 3 dx. So that takes care of the 3. So integral e power 3x 3 dx is integral e power u d. E power u integration is e power u plus c. But u was 3x. So e power 3x plus c. So plus c has been taken care of. E power 3x. Okay. Next problem. This is the last problem. Integral e power 9x times 3 plus e power 9x the whole power 5 dx. So you can see there is some substitution. Okay, because that's the complicated one with a power of 5. So you need to substitute all of that. All right. So you take 3 plus e to the power 9x, call that u. All right. Then du is, that doesn't give you anything, but derivative of this is e power 9x, because that's exponential, times chain rule. Derivative of 9x is 9. So du is all of this. So that takes care of e power 9x and dx, but there is an extraneous 9. So divide both sides by 9. Du by 9 is e power 9x dx. So the required integration is integral e power 9x 3 plus e power 9x the whole power 5 dx is 1 over 9, that's the 9, integral, all of this was u, power 5, e power 9x dx is the du over 9. All right. Okay, so integral of u power 5 is u power 6 over 6 plus some constant. Okay, don't forget you have a 1 over 9. So that constant I'm calling it d. Now when I substitute the 1 over 9, I get u power 6 over 54 plus 1 over 9 times d, which is some new constant. That's all. The question was in terms of x, so answer should be in terms of x. Replace u by 3 plus e power 9x. So that's your integration plus c. So let's write this down carefully. Plus c part they have given us. The rest is a fraction. Denominator is easy, 54. Numerator is something power 6. All right. Now what goes inside? 3 plus e power 9x. Okay. Fantastic. So that completes our problem list. Next videos will continue with our topics. So to inform everyone, I'm following closely the text by James Stewart, which is the textbook for our class. Okay, bye.